Hello students and welcome to the class. In the last class we had a discussion about alkane, alkene and alkyne, and with their general formulas how you can make their structures and electron dot structures we have learnt all. Now in this class we will talk about chain, branches and rings, and I will show you a video. Through that, all these structures they are showing you, so it will make you more clear about it and you will able to learn it much better. So let's go and watch it.
Straight chain and branch chain. If we take the example of pentane C5H12, we can see that different structures are possible. In the above compound, the carbon atoms are linked together in the form of open chain. These compounds can also have branch chain. Compounds with identical molecular formula but different structure are called isomers, and this property is known as isomerism. Thus, these three structures are isomers. When the two ends of the carbon chain get bonded, forming a closed structure, then the compound formed is a cyclic hydrocarbon. For example, cyclohexane C6H12 is a cyclic hydrocarbon. Structure of benzene C6H6. Benzene ring consists of a cyclic structure made up of 6 carbon and 6 hydrogen atoms. Each carbon atom is bonded to another carbon atom on one side with a single bond and a double bond on other side.
Students, we heard today a different term, and that was isomers. So just to make you clear with the concept, what does it isomers mean and how it comes? What is same molecular formula and different structures? What's that? So to understand that, I have this video. Watch it carefully.
This video got us introduced to a unique concept of homologous series. That is the concept in which compounds with the same general formula appear in succession. Now in this video, let's get introduced to another interesting concept. What if I tell you that there are many carbon compounds which possess the same number of atoms in them but have completely different structures? What do I mean? Can there be compounds that have the same number of atoms of each element in them but arranged differently? Yes, this is the concept of isomers. Isomers is the term that originated from the two Greek terms, iso meaning same or equal and meros meaning parts. Thus, here the term represents the compounds that have exactly the same number of atoms of each element in them. However, the arrangement of these atoms is completely different. For the sake of understanding, let us assume we have a compound like this. There are 2 atoms of A, 1 atom of B and D, and 3 atoms of C. Now look at this structure. The number of atoms of each element is the same, but the structure is different. There could be many more combinations that could rise if we rearrange the atoms. All these structures can be called as isomers of each other. How do we define isomers then? Isomers can be defined as the compounds which have the same molecular formula but different structural formula and thus different properties. That means if we take molecules of the isomers and compare them, then the number of atoms in each molecule will be the same, but their structural or spatial arrangement will be different. Wait.
See students, today we will focus on chain, branches and rings. Okay, so let's focus. Like chain we have already done. You have already seen how chain forms. Okay, so this is clear to you. I don't have to explain much about it because you already know about it. We have already made structures like this. Okay, now branch students, if I talk about branch. Can you draw this? Can we draw this? See, 3 carbon atoms, and we can form a chain like this. See, so it is a structure. Which structure it will be? Do you have any idea about it? Which structure it is? Yes, it is. If you want to talk about, then so students, see, I have made the structure for you. What we will name it? How many carbons we have? 1, 2, 3, 4. So C4. How many hydrogens are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So H10. You can write this formula like this also. We will understand it far better. I am just giving you an explanation now. We will understand. If you have any kind of problem then how we have written this, we will understand. We will slowly understand everything. So don't get panic if you don't understand something here. CH3, CH3, CH, CH. This CH3 I can write on the top also, here also. Okay, if I have not written here, I have written here. If you don't want to write here, you can write over here also. Okay, and then CH3. So this is the molecular formula. Okay, so now students, what we name it as? Isobutane. Okay, it is a structure of butane. If you have only one chain, one branch over here, we can call it as isobutane. So now students, we will write about pentane. Okay, we will study about pentane. So pentane structure, chain structure will be like this. 5 carbon atoms, put all the hydrogens. Okay. So students, we were studying about isomers, okay, and we were doing about pentane. We were doing about isomers of pentane, okay. So see, we have 5 carbon atoms. Here I have broke the structure and I have put carbon over here. And what I have got, this is called, just like isobutane, I got isopentane because I have arranged it here only, okay. One branch I have given. Here 2 branches are there. So when 2 branches, we call it as neopentane. So this structure is possible in pentane. Okay, you cannot make this structure, this neopentane, you cannot get in neobutane. Okay, because these chains, you have to form it in a proper way. Okay, so there's a proper way of forming chains. So you will not get all the structures in every compound. There are some compounds where you will get all these things. Okay, students, see, rings. In front of you, I am showing you a ring. Carbon with hydrogen can form ring also. You already know a very popular formula, that is benzene. Okay. Here you see structural formula of cyclohexane. This is C6H12. It is C6H12. Students, you have to draw the electron dot diagram for C6H12. This is your homework, that you have to draw the electron dot diagram. Okay. And in case any kind of problems, you can talk to me. Students, these are some practice questions. You have to do this after completion of this isomers topic. Okay. In case you have any doubt, we will talk in our online classes. So do all the work. Take care and bye-bye.